Hello everyone, welcome to Automation 24/7. In this channel, you are going to get videos about Java, Selenium, and basic coding skills that a quality analyst or a software tester needs. So, in this video, I'm going to demonstrate about how to find whether a number is prime or not in Java. So, this is my first video. Let's start. So before finding whether a number is prime or composite, let's understand what is a prime number. So prime number is basically a number which has two factors, that is 1 and the number itself. So if I consider 5, 5 is a prime number. Why? Because it has 1 and 5 as its factors, that is, it is divisible by 1 as well as 5. If I consider 6, 6 is a composite number, that is, it is divisible by 1, 2, 3 and 6. If I consider 9, 9 is also a composite number. Why? Because it has factors like 1, 3, 9. So prime numbers are those numbers which has only two factors, 1 and the number itself. And not prime numbers, basically the composite numbers, are those numbers which has multiple factors, that is, it can be divisible by 1, the number itself, and other numbers also. Now if you consider 0 and 1, 0 is basically not a prime and so is 1 not prime. The reason is 0 does not have any factors, because any number multiplied by 0 is 0. So as per the definition of prime number, it should have minimum two factors, 1 and the number itself. So we cannot say 0 and 1 as prime numbers. For 1 also the same logic, like 1 has only one factor, like 1 multiplied by 1 is 1. So apart from 1 there are no factors. So both of these are not prime numbers. Now if you consider 2, 2 is the least prime number, because 2 has two factors, 1 and 2, that is, 2 is divisible by 1 and the number itself. Excuse me. So the least prime number is 2, and after that, based on its factors, like if it has two factors, then it's a prime number. If it has more than two factors, like more than 1 and the number itself, other than that, if there is any other numbers that is divisible, then that number is not a prime number. Now there are two ways that I am going to show how we are going to find whether a number is prime or not. It's very simple, and this question is asked in most interviews. The Java developers, if they're looking for any job as Java developers, or even for software testers, or any quality analyst who wants to learn Java in Selenium, they might be getting this question, and it's the very basic coding question. So there are two ways which I'm going to show you. First one is basically a very simple one. Okay, so what is that I'm going to do now? Before writing the code, I'm going to write the algorithm for that, because before writing any code, it's always required to write the algorithm to gather the steps that we are going to follow, that we are going to achieve to run the program or to achieve the desired result. So the first method is basically, we are going to enter a number, then we are going to scan the number, and that is very important. We are going to scan the number. Next, basically, we will be taking a count value. Now this count value is going to decide after I'm running a loop, this count value is going to decide whether the number is prime or not. So the next step, basically we are going to start a for loop from I equals to 1 till I less than equals to num. Now this num is basically this number that we have entered and scanned. Okay, so this is that num. Now I plus plus, and for each iteration we are going to check that if the number modulus of each ith value is equals to 0, then we are going to increase the count value. So we are going to increase the count value, right? We are going to increase the count value. So as you can see, this I equals to 1 till I less than equals to num, and after the increasing it, I plus plus. Under that we are going to check, like at each value of I we are going to divide that number with each value of I, and if at each iteration we are getting the remainder equals to 0, then we are going to increase the count. So for example, let us take this example. If my number is 5, like num equals to 5, then what will happen? At I equals to 1, it will be checking I equals to 1, I less than equals to num. So I equals to 1, I less than equals to 5, correct? I value increases, and what it is going to do, it's going to check 5 modulus of 1, right? So 5 modulus of 1 is 0, so my count value increases here. So here my count value becomes 1, right? And then my I becomes 2. My first iteration gets completed, condition satisfied, and as because num modulus of I equals to 0, that is 5 modulus of 1 equals to 0, so my count value becomes 1. Now when my my ith value is 2, num equals to is 5, I equals to 2, I less than equals to 5, yes, that's true, I plus plus, so 5 modulus of 2 equals to 0. No, it's not equals to 0. So my count value does not change from 1 to 2, it remains 1, right? Now at I equals to 3, num equals to 5, I equals to 3, I less than equals to 5, it's true, so I plus plus, 5 modulus of 3 is equals to 1, not equals to 0, so my count value does not increase. As you can see, if num modulus of I equals to 0, then only my count value will increase. Now why is the logic so? Because prime number can have only 2 factors. So here count, we are actually getting how many factors. Okay, so if prime if the number is prime, then it will be having more than 2 counts. So here count still is equals to 1. Now my ith value is 4. I less than equals to 5, fine. 5 modulus of 4 is not 0, so false, count value does not change. Now my ith value is 5, I less than equals to 5, yes. Now 5 modulus 5 is equals to 0, my count value changes. Now again I equals to 5, I less than equals to 5, so it will be coming out of the loop, because from I equals to 1 till less than equals to num, so I've completed my iteration from I equals to 1 to I equals to 5. So after that, what I'm saying, my count is 2. Now if my count is 2, if count equals 2, then prime, else composite, right? So this is the first way. So let's go to our ID. So I have my Eclipse ID and I have created already a project. So let me create a package. Now I will be explaining later what are packages, what are classes, how we are going to create that. Okay, so all these videos are coming as soon as possible, and here just I'm creating the package name. Right, so I've created the package. Now I'm creating a class. So this is the first way of checking whether a number is prime. That is why I've given prime number 1. Excuse me. So following the algorithm, enter a number, scan a number. So what I'm going to do, I have to enter a number. So before that I have to just write system.out.println, enter a number, and basically after that what I'm going to do is I'm going to scan the number. So I have to import the package for this scanner, java.util. So I have imported that. Now basically what I have to do, I have to scan basically this number. So this int is basically the number what I have entered. I will be entering into the console, so that it will be scanning, and it will be storing in this num variable, right? So I have entered the number, I have scanned the number, and what basically I have to do, I have to declare count as 0, because this is basically on which I'm going to decide, or my for loop is going to decide what is my count value, and based on that the number will be prime or not. So before that, so basically what we are going to do, we are going to start the for loop as I said. So I'm starting the for loop from int I equals to 1 till I less than equals to num and I plus plus, right? Now into this for loop, the logic what I've written is if num, so this is basically that num that I've written, so count plus plus right. So count plus plus if under for. Now what I'm going to do is basically if count equals to 2. Okay, that is what I've written. If count equals to 2, so that becomes my prime number. So my number is prime, else not prime, or number is composite, I can write, right? So I have written the program. So from I equals to 1 till that number, if at each iteration I will be just like this loop will be dividing that number with that each iteration of 1. Now anytime if it becomes 0, like if it gets a remainder, so count value will increase, and according to that count value, if 2 times we are getting the count value, like if the count value is basically 2, that means 2 times we are getting the remainder as prime, I mean the remainder as 0, so it's prime. that means divided by, like the number is divided by 1 as well as the number itself, or else if it's more than that, then it's composite. So let's just check once. So I've entered 9, 9 is composite. Now let me enter 5, number is prime. Now suppose if I'm entering 0, then what is going to happen? Because let's just check. So 0 is composite, but as per the logic it's wrong. If I'm entering 1, what is 1? 1 is composite. So we have to write another two things. Okay. Here I'm going to write one thing. So if number equals to 0 and if number equals to 1, then it should not be showing as number is composite, because for 1 and 0 it should show number is neither prime nor composite, but for other numbers the logic is same, like based on the count value it will just check. Okay, so let's discard this basically. Let's discard number 0 and 1. So 0, 1, 1 is basically, we are not going to consider right now. I will be coming up with other videos to check, to basically like show you if we are entering 0 or 1, then what's going to happen. But for other numbers from 2 to any other numbers, we are going to follow this process. So this is one of the method. Okay, so 2 is the smallest prime number. So this is the first way. This is the first way that we have checked. Now coming to the second way, right? Coming to the second way is basically what we are going to do. So in the first method, I mean the first way, what we have done is we have entered a number, scanned a number, so the first two things will be same. Now I would recommend you to go with the first process, like with the first method, because it's a very simple one, and if you want to use the second way you can. So coming to the second method, the second way of checking whether a number is prime or not. So we are going to enter a number, after that we are going to scan a number. Both the steps are similar according to like step 1. Now what we are going to do is basically, here we have declared count equals to 0, and this is going to basically decide what will be my number. So in the second method, in my second method, what I'm going to do, I'm going to declare a flag which is by default I'm taking it as false. So I'm just taking a flag which is, say it's a false, it's false, boolean flag equals to false, right? Now here we are going to start a loop from 2, right? So if I'm considering int I equals to 2 till int I less than equals to number divided by 2. So here we started with 1. Now we are going to start from 2. Why? Because 2 is the least prime number, right? So from 2 till that number divided by 2, we are going to check, and basically the same thing only, just we will be checking the modulus operation. If that is coming to 0, then we are going to change the flag value. Like previously we changed the count, we increased the count value by 1. Here we are going to change the flag value. So what we are going to do, if num, I mean the number that I have entered, which is basically this one, the number which I have entered and scanned, so number modulus of I, if that becomes 0, right? So if that becomes 0, then the flag value that we have entered, so that flag will be set to true, and we are going to break out. We are going to break from the loop, like we are going to come out of the loop. Okay, whenever we will be getting the flag value as true, we will be coming out from that loop, right? So the next step says, if flag is basically like my flag value, if my flag value equals to false, okay, if my flag value equals to false, then system.out.print number is prime, else number is not prime, or you can say composite, right? So the same logic, but it's going to check from 2 till the number itself. So if I consider say 5, right, 5 is the number. Now 5 so what we are going to do, 5, then considering I less than equals to num by 2, that means from 2 which is less than equals to 5 by 2, that means 2.5. okay, so yes, 2 is less than 2.5, and we are going to do the I plus plus, so I value gets increased. So this condition is true. Now basically the number that is 5 will be dividing, like taking the remainder out of it by dividing it by 2. So 5 divided by 2 is not equals to 0. So flag is still false. So here we have checked from 1 till that number, and here we are checking 5 till the half of that number. Okay, so half of that number means here we are going to just check, like if once the flag value becomes false, then only number will be prime. So we are not going to iterate till the number, we are going to check just the half of that number. Okay, so number divided by 2, it's similar to what we can check whether, like if suppose the number is 5, so half of 5, right? So we are not going to check till the whole number, so till half we are going to check, and if any time in between the flag becomes true, that means it's a prime number. So now value of I becomes 3, is less than equals to, is like 3 is greater than equals to, sorry, 3 is less than equals to 2.5. No. So my flag value becomes false only, it comes out, and here my flag stays as false, right? Flag stays as false only. Now suppose I am checking for 4. So i's value is 2. 2 less than equals to num divided by 2, which is 2. 2 less than equals to 2. Yes, so 4 divided by 2 is equals to 0. My flag becomes true, and it will just break because my flag became true. So it will come out of the loop, and it will be, the break operation will be activated, like break will be happening, it will be just breaking out from the loop, and my flag value will be true. So here was what we are saying, like it's just checking till half of the number, so not iterating so much and just doing num modulus of I. Here it is checking from 1 till that number. Okay, so both the methods are fine, so whichever suitable you can apply in your programming or wherever asked in interview. So let's implement the second method. So the second method is basically I'm going to create another class excuse me. So prime number 2, so I'm just going to copy this, right? Now here we declare int count equals to 0. Now here what we are going to do, we are going to declare a boolean flag. Boolean flag equals to false by default, right? Now what we are going to do, we are going to check with this condition. So we are starting from 2 till half of that number, so it will not just iterate that much, it will just stop till its number, like half of that number, and if at any time it gets 0, okay, so it will just stop, like it will just break out, I mean, and the flag will be true and it will break out. So the logic is more or less same. In one condition we are in one method we are just considering the number as prime based on the count value, and in another method we are considering number as prime based on the flag value, and in loop we are considering half of that number, not going through the whole number, right? Like total, like that particular number, we're not going till that particular number, we're just considering half of that number and just taking it. So if flag equals to false, so let's run. Number is composite. Again I'm going to run. Number is prime, right? So as you can see, these two methods will help you on deciding whether number is prime or not, and in upcoming videos I'm going to modify this prime number and check with 1 as well as 0, because if like interview may ask, run this program and enter 1 in the console, so how will you do that? So I'm going to come up with 1 and 0 to check whether 1 is showing prime or not, because 1 and 0 both are neither prime neither composite. Okay, so how we are going to show that in programming, so we'll be explaining that in the next video. Thanks for watching. Hopefully this will be helping you in the interviews as well as your learning process in programming. So thanks for watching. Keep subscribing Automation 24/7. Thank you.